In 1909, an earthquake hit near the capital city of Croatia. Andrija Mohorovičić was a seismologist, someone who studies earthquakes, and when he took a look at the seismographs, what he saw truly surprised him. He saw that certain waves refracted or bent and didn't go in a straight path, and other waves, S waves, that he knew couldn't go through liquid rock didn't appear on the other side of the Earth at all. This led to several observations. First, that the speed of a seismic wave is going to change after it passes through the top layer of Earth. Second, the shadow zones from the P waves because of the refraction, and the shadow zones of the S waves because they don't pass through liquid. This observation led to the idea that Earth has different layers with different densities, and the seismic waves are going to act differently in different densities. When you have two substances that have different densities, the denser one will always sink, as in the example of oil and water. When it comes to the materials that compose Earth's layers, the denser materials are going to sink towards the center. Eventually, this led to the model of Earth's different layers. However, nobody ever went all the way down there, but this is based on Mohorovičić. The first thing is that the surface of the Earth is just a tiny portion compared to the rest, and the surface is going to be different than the layers underneath it, or discontinued. This separation is called the Moho, based on Mohorovičić's name, and shows us the separation between the top and the rest of the layers. The top layer is the thinnest, and it's called the crust. Continuous unbroken rock of the crust is called bedrock. Crust on the land is going to be thicker, but less dense than crust under an ocean. Because of this, the ocean crust is going to sink underneath land crust. Up top, you can see the densities of the two crusts. Continental crust is going to be 2.7, while oceanic is going to be denser, being 3. The crust sits on the thickest layer called the mantle. The crust and the outermost layers of the mantle are solid, and together they are called the lithosphere. Most of the mantle is solid, but high temperature and pressure cause the top layer to be liquid in some ways, called plastic. The lithosphere floats on the asthenosphere, aka plastic mantle, which is responsible for the movement of our crust, but more on that later. The next layers are the core layers, which are made of iron and nickel. The outer core is rock in a liquid state. We know this because S waves cannot pass through it since it gets absorbed by liquid rock. However, the inner core is still solid. On the surface of Earth, the temperature is based on the sun's heat. For example, inside a cave will always stay the same temperature since neither the sun nor cold weather will reach inside it. But inside the Earth, as you go deeper, it gets warmer as well as higher pressure. These two graphs are part of the same reference table that show Earth's layers, and they show as you go deeper into the Earth, the temperature is going to rise, as well as the pressure. As you go deeper, the pressure is going to rise. These graphs match up with Earth's layers, and these lines represent the boundaries between the layers. By looking at this line, which represents the depth of Earth's layers, and where it meets the graph at any point, you can go to the side graph of temperature, which will tell you which temperature it is, as well as on the pressure graph. You can follow the line, depending on which depth, and follow it across and see what the pressure is. So to recap, the layers of Earth are separate because of the different densities, and temperature and pressure will increase as you go deeper. That's all you need to know for today. Please make sure to answer the questions correctly. Thanks so much for watching. Have a great day.